some connectivity issues are still there, I think. Anyways, start recording and proceed.
The recording started. Hold on.
A very good evening and a warm welcome to everyone present. Today, we all have gathered here to witness the 16th lecture of Centenary Lecture. Today, as our chair, we have with us Professor Sudipta, Professor, Department of Civil Engineering, IIEST Dhanbad. He is also our beloved alumnus from the batch of 1988. Sir, I would request you to take over the session as the session chair. Over to you, sir.
The voice was not good, but anyway, may I request our today's chairman to take it over and start the session. Professor Datta, please.
Yeah, good evening to everybody, and I would like to convey my respect to my senior professors and the best wishes to my colleagues. Well, I am a little bit odd man out in this whole lecture series, I think, because I belong to civil engineering and the whole lecture series of mechanical engineering. So possibly I'll not be able to say anything which is, anything from the technical points of view, but I'll try to remember some memories which I share with Professor Sudipta there. And both of us used to stay in the same hostel, hostel number 9, and he was just 1 year junior to me. And we had a very good heart-to-heart relationship in the sense that, both of us were really lover for mechanics. So that was the common point of discussion, and very often we used to have discussion about it. And that way he became a very good friend of me, and that friendship continued. Of course, now for a long time we are disconnected, but still I think that whenever we will meet, we will again speak like those days. And Sudipta is doing excellent, that I came to know from various electronic media, that as professor he is a very successful professor, and it is quite expected, because the person who is really having the passion for mechanics, then he will do very well in mechanical engineering, and possibly his specialization is thermal engineering. Am I correct, Sudipta? Hello?
Yes, absolutely. Thermal engineering was but now I will tell during my presentation, slowly I'm moving towards interdisciplinary energy approach.
Yeah, okay, yeah. Now I see that you are moving towards energy, which is really a flourishing area, and the clean energy is one of the very great challenges, and so I believe that this will be a very successful journey for a scientific explorer like you, and it's really the need of the hour to work on this. So I wish you all success in this endeavor, and I hope that we should keep in touch with each other, more frequently. So with these few words, I would like to give introduction, and his academic introduction might be given, at present his academic introduction might be given by maybe Dr. Sudip Ghosh or somebody else who knows him from the viewpoint of the recent activities much better than me. But we are just good friends, and the common point is that both of us really love mechanics, and that possibly brought us together. So with these words, I would like to say that So with these words, I'd like to hand over the mic to Professor Sudipta De for starting his lecture.
So should I start with the permission of the organizers? Okay, as the chair has permitted me, I should go for the presentation. Fine. Become the presenter. Yes. We have to continue. Yes. Then share. Yeah. From beginning. Yeah. So just let me arrange the things. Otherwise, it will create problem. Okay. Let me put it down. Okay. So thanks to the organizers. It's a really, really great opportunity for me. Sharing some of my ideas and works with the seniors. I think pretty good, seniors and some of my teachers, and then to my contemporaries and to the younger students. It's a centenary year for my alma mater, and I'm really feeling myself lucky to be part of this particular celebration as one of the speakers. I chaired one session, but talking to the people in my own area is something different experience. And my sincere thanks after the organizers is to Professor Shekhar Datta. I should not call him Shekhar Datta, I should call him Shekhar Da, because we are so close. We should not call Shekhar Datta, Professor Datta or Professor De like this. And I remember this Shekhar Da would ask some difficult questions on mechanics during our hostel days, staying together in Hostel 9. And I had to answer. If I cannot give satisfactory answer, he just started haunting me for the whole day. That's not proper correct. That's not the proper concept. And I remember that how the mechanics was revised after high secondary with staying with Professor Shekhar Datta or Shekhar Da. Anyway, he has also mentioned that. But after the mechanical engineering graduation, interestingly, some of the teachers had strong influence. And I had the strong influence of two of our legendary teachers, Professor D.N. Rai and Professor Pannapal. And I thought that the thermal science I liked more than that, than mechanics in our further studies. And I opted for thermal science later on. But currently, as Professor Datta has mentioned, that though my specialization area in master degree and even in PhD, purely it was in thermal science, because my PhD was, my first love was coal, because my entire thesis was in coal-based energy. But interestingly, later on, I found out that the possibility of existence of coal-based power is not suitable for the academicians for a longer career. So I opted for the renewable energy options. And now I'm trying to, whenever I'm trying to enter into the energy area, that I cannot be Puritan about a particular specific discipline. In my group, actually now electrical engineers, electronics engineers, chemical engineers, they all are in my group, some from different fields. And I also start enjoying and start learning from them. Because honestly speaking, some of the works I will present here today is beyond my full knowledge. Some electrical engineering inputs they have given, some electronics engineering inputs they have given, because especially in renewable energy integration, there is no other option than to be multidisciplinary. What I will do in this presentation, let me explain it very clearly today. As there is a mixed population here, I don't know, it may be from different disciplines also, and specifically from very experienced senior, my respected teachers like people, and up to the students. I will not go into in details of the methods, whatever I have done, but I will try to highlight what has been done and what was the objective, and a little bit summary about the implications. An overall goal of this presentation is not going into actual academic technology analysis, but better to see with respect to national goal and what I feel regarding the future possible option. And obviously, this is, I'm not concluding. That's why my presentation is also starting with a title with question mark. So I'm just telling from my research experience with my group, I'm feeling something like this. Whether it will happen in future or not, nobody knows. Let's see what I just want to present. It should come through enter. Oh, no, for this one. Let me check how it will come. Point. Yeah, coming. So I'm just making some Indian power. I guess I'm audible to everybody and the slides are visible. I'm just checking once.
Yes, sir.
Okay, good. So I'm just reviewing some facts of Indian power. This is the scenario just taken yesterday only, updated data from the Ministry of Power. And interestingly, if you can look into that, that still we are fossil fuel dominated power in our country. Out of total power, around 60% power is coming from the fossil fuel based system. And undoubtedly, coal is the most important single component for power supply in our country. But interestingly, we have significant growth with respect to non-fossil fuel development also, out of which the 40.3%, even 10 years, 15 years back, is we couldn't think. The renewable energy based systems were only some laboratory based demonstration or some just for prototype development sort of thing. But within the last 10 years, I must say, substantial progress has happened with the demand of this particular world moving towards sustainability or low carbon solutions. Now, the specifically out of this non-fossil fuel based power, I'm interested with the renewable, because nuclear, I must say, it's a controversial area worldwide. Though nuclear was thought of initially for the transition from the fossil fuel based system to the renewable system, in between the buffer, at times thought that nuclear would be the best possible solution because it has got large power capacity without very minimum environmental pollution during operation. But especially due to 2 or 3 accidents worldwide, the people became very much suspicious about it. And interestingly, in worldwide development, you know that the people's perception at national level matters a lot. Whatever may be the safe technology, whatever may be the available development, unless people accept it, technology never becomes publicly successful unless it is socially accepted. Nuclear, to some extent, has not been accepted worldwide, and there are a lot of controversy and debate. I'm not telling that all are true, but people perception is something, whether it is true or false or wrong, people don't want to ask. But in national voting system, many country has rejected nuclear power growth. Anyway, so renewable as such, nobody has got rather so-called reservation, but undoubtedly the growth of renewable has got many constraints, but compulsion too. So 38.5% of the total power of India, according to Ministry of Power, is an important development that we should go towards more renewable power. Now there is the next slide. I'm just trying to show the annual growth. In fact, the 2021 and 21-22, the last 2 years, is not very reliable trend to observe, because that started from 290 to 220 even, due to the pandemic situation. So fluctuations or other aberrations were there in all the fields in power generation too. So if I take a trend up to 18-19 from the previous years, you find that there is a steady decline of the growth in fossil fuel development, fossil fuel based power development, and similarly there is a steady increase of the renewable power generation, barring few exceptions of 1 or 2 years. So it is expected that the trend shows that renewable power will increase in national power mix, and that's international compulsion too now currently. So this is the value of the so-called the fossil fuels and the renewable growth, as I have taken 18-19 as the reference here, because the next 2 years almost, from starting from the early part of 20 up to this, the pandemic effect is there. Now there is what is the source of inefficiency of this large coal-based power plants? Mostly in our audience, I can expect that mechanical engineers are there. There may be some other disciplines also. But mechanical engineers, from their basic undergraduate knowledge of power plant engineering, they know that the plant load factor is an important issue. Plant load factor means what is the plant designed for, and then how much percentage of that capacity is being used. Obviously, plant load factor higher, maximum value of 1 or 100% is the desired option, most desired option, because you can operate your plant with maximum possible efficiency. But unfortunately, that doesn't happen in reality, because all of you know that electricity, large-scale storage is yet not available. So in electricity, generation and consumption, there must be somehow a parity. Making the grid makes a particular buffer solution for this, any gap between the demand and supply. But still, large gap between demand and supply will lead to failure of grid unless we take some special measures to protect that. So running a power plant at a lower plant load factor is distinctly an indication of central coal-based or fossil fuel-based power plants are running at lower efficiency at national level. Interestingly, forget about the private sector, because private sectors have a lot of issues, but still they are also showing in between. But the central and the state power sectors has got the plant load factor of the order of 64% and 50%. The message is there is certain issues or problems with these power plants, because though they are installed up to a capacity of 100%, out of which at the state level we are only 50% can use. So rest investment in the infrastructure, the efficiency of that particular operation, all are getting affected at the central power plants. These are the two issues which makes sometimes a lot of discussion. One is the transmission and distribution loss, another is the AT&C loss, associated technical and commercial loss. Specifically to the students, I must say that what you learn in your degree or your further studies in academic institution, these are engineering principles, mostly engineering sciences, to some extent technology. But when you go to the industry, making balance of the revenue earning is the most important thing. Nobody can deny. So I work with Bengal Chamber and other industry houses, and I know from their experience, from those experiences, that whatever may be the best technology academically, it will never be viable unless there is a good return of revenue from that. So these two parameters must be considered as at a policy level for choosing for alternative options. Transmission and distribution loss, I will give the formal definitions just later on, the next slide. But obvious it is that whatever you generate, out of which you have to transmit it to at the point of consumption. And as you know, why this electricity is considered to be one of the, rather the best possible, not one of the best possible secondary energy option, is because it can be transmitted to a very large distance, a long distance, without any significant loss. Say heat energy generated at a point cannot be used, say at a distance of, say, not more than some few kilometers. Even that's also not very safe, because providing insulation will not retain that particular heat loss. But electricity can be transmitted over several, even some of the order of some hundreds of kilometers through the grids. So the transmission and distribution loss indicates that whatever you are putting into the grid at the generation point, and finally what you are receiving in between. This transmission and distribution loss has some part with respect to technological issues, because obviously whatever may be the smaller loss that will be there during this transmission, because all of you might be aware of the very basic fact that transformers are used during this transmission process, where initially at the generation point you have to go for step up transformer where the voltage will be increased, and then the entire transmission has to be done in a very high voltage, which is requirement for lesser loss. And then at the distribution point you have to bring down that particular voltage at a lower value, and then you distribute locally according to the local voltage of the domestic supply, and industrial consumption can be at higher voltage also, and as per requirement the distribution point will set their step down transformer. So based on this principle, technological losses are there. But whenever you are assessing that particular loss from a company viewpoint, and now all of you might be aware that the generation and transmission distribution has made into two verticals. Previous concept was they were combined together in a single utility company. But now the generation and transmission has been made two verticals with a very important reason, due to very important reason, that to identify the source of inefficiency. And from that viewpoint, the transmission and distribution loss may not be necessarily always due to technological losses. There are social issues. Say, tapping of power, unauthorized power is a serious issue in India. So even in many national meetings, when I joined, I found out that the industry people are referring transmission and distribution as theft and dacoity loss. Means there are certain losses in many states, that's a very high amount, that this loss also causes to the effective transmission and distribution loss, though the cause of that transmission or distribution is not due to technology. And associated technical and commercial losses also, if you can find out that these two losses are decreasing over the years, that's a good sign. That's why I'm happy. But still, the worldwide good average is of the order of 8%, where in even 1819, we have a value of around 20.66. In fact, this table I have got up to 14, 15 from a CEA presentation, and the rest 3 years I have added up recently, got it from another source, but not I have got the AT&C value. But anyway, that doesn't matter because the transmission distribution loss percentage is directly connected to the AT&C loss. So these are the definitions as I was discussing. Transmission distribution is purely with respect to the energy billed by the total energy input to the system. But AT&C loss is basically billing efficiency minus multiplied by collection efficiency, means the transmission distribution is assessment is with respect to the energy part, and this is associated technical and commercial losses with respect to revenue earning. Maybe energy is supplied or delivered to the person, but due to some subsidy principles, money is not being earned. So obviously that may contribute to the AT&C loss, but not to the transmission and distribution loss. But generally for a company, that's the loss either way, or rather finally AT&C loss is the most critical part because that contributes to the financial earning of the company. So centralized distribution system has got this limitation. Transmission and distribution losses will be there. You cannot just make it to zero. At least the worldwide average is also 8%, and ours is more than 20%. Now coming to another fact, you know that the majority of Indian thermal power is from fossil fuel, and out of that, coal is the single largest fuel from which you get the power. And the coal distribution, as it is shown in the map, majority in the eastern part and some in the southern and central India also. But where is this coal consumed? The largest power plants of India are either in northern part or in the western part. That planning has to be done according to the industrial growth and many other issues over the 5-year plans. But interestingly, the source of power, fuel, is somewhere in the eastern part, southern part or central part, and largest consumptions are in western and northern part. You have to transport the fuel, and there lies another problem or difficulties. Almost 45% of the overall freight movement of the Indian railway is due to coal transportation. So we are consuming some part of our own energy for the transport of energy itself. Is it not a fallacy? We have to accept it, because if our consumption point and generation point, or rather extraction point of coal, would be very close, that's a theoretical proposition. We academicians always go for good assumptions, but that may not be the reality. Anyway, so we have to transport the fuel, means with respect to energy efficiency, we're also losing it, but no option, because already installed large plants are on the western side. And that effect I will show in my published paper when I refer to that eastern part, though they are producing maximum power the resource fuel for the power generation, but they are the largest deficit with respect to the power supply. Anyway, that's with respect to national planning and many other socio-political issues. I'm not going to make those issues because those may be the research of the socio-political scientists. Then we have a bootstrap problem. We initially made our infrastructure towards coal-based power just because we had large, or rather we have also large coal reserve. We are within first 4 to 5 countries. Last time it was 4th, most probably currently it is 5th largest country of coal reserve with respect to known coal reserve. So some more new mines may come up. But interestingly, though we started our entire power sector dominated by coal, later on we found out that this coal is a poor quality coal with respect to high ash content. So with respect to business, when the people are going for business, especially the private sector, they prefer better coal for better efficiency, for better profit, etc. So what happened? Then obviously the people have started importing coal. So we started just because we have large inventory, then we have opted for importing. So that was not that much problem initially, but later on it was identified the source of carbon emissions. We are being identified for imported coal also. So the coal has been imported from Australia or Indonesia or South Africa, but the generation point of carbon dioxide will be responsible for the CO2 emission as per the climate change regulation. So we are emitting more carbon than our own resources, but also from the imported coal. Now some effect. With respect to deficiency of the gap between demand and supply, I must say that India is progressing very nicely. This is Ministry of Power's data, statistics. So deficiency is decreasing, and that's really a good news for all of us. We should be happy with that. But still there is a deficiency. Many people may argue with this, that these data are to some extent synthetic in a sense. Unless we can reach the demand of the entire country, every people, we are not providing electricity still to everybody, though there are several projects or other policy planning has been met. I will refer to those also. So this data, whatever has been provided, are they the actual real data? I'm not going to that controversy, but I'm accepting as this is the government published data as a general tendency of decreasing the deficiency, both with respect to peak load and with the general overall integrated energy deficiency. But interestingly, we have to note that this particular deficit, as has been identified, is rightly, if your electricity connections increases, really this will be much more than the declared one. Now, government initiatives. Problems will be always there, and we have a general tendency to criticize the government because we are not getting anything, so government is responsible. But government has to take the initiatives, which is very much difficult to implement in a situation, but government has to try also. That's their responsibility. That's why they are in the government. So whatever the government initiatives are there, some initiatives I'm referring to. Electricity Act in 2003 was a very remarkable development with respect to pure accounting of the electricity consumptions, and those Electricity Act in fact very clearly told about the unauthorized use of electricity, punishment, etc., etc. And that also given importance for the rural electrification. Rural electrification policy was adopted in 2006, though it committed provision of electricity to all households by 2009. Honestly speaking, in reality, it may not be the situation. Rajiv Gandhi Gramin Vidyutikaran Yojana, this was also to supply the power in below poverty line. We must have to admit these because these are the officially announced programs of Government of India. Then remote village electrification program is another very important concept. In some of the areas of India is quite lucky to have a quite variety of topography. We have Himalayan hills, we have long coastal area, we have different other places, and we have the deserts. So everywhere the grid-based power may not be equally good or rather viable with respect to the revenue generation. One of the area, we are in West Bengal, so we can refer to that because I know the Jadavpur University was involved in the project of renewable energy introduction into the Sundarban area. Because in Sundarban, it's such an area where the grid-based power will never be feasible. In a sense, maintaining grid and getting proper revenue from that with grid-based power supply may not be good, may not be rather feasible. So I know that I cannot just remember the exact year, but around some 95 plus, 1995 or so, there was the initiation, and then around before 2000, there was the installation of many solar-based systems in Sundarban area, and which has remarkably changed the socio-economic structure of that particular locality. Previously, without having any power, people would simply sleep just because when the sun sets, because they have no other option. They're too poor to get any light and do anything. But with the solar introduction, now even the social activities and economic activities are going on even beyond the sunset that is expected. And there is substantial social development in those areas with that electricity introduction. So why I'm specifically mentioning that point is remote village electrification should be a priority area for Indian social development. Now, two specific policies I must mention. One is the Integrated Power Development Scheme, IPDS, which actually work towards the better metering. That means sometimes there was a standard statement of the highest officials of NTPC and government, the Ministry of Power people. They tell Sat Pratisat metering. That means 100% metering has to be there. Interestingly, the IT enablement was required, unless if you just want rather IT enablement was very much required because IT based technology has developed in the meantime. to get an accurate estimations of where is the loss that can be identified easily in an automatic system through IT-based technology. And recommendations was there, it must be implemented as far as possible. But the other one, you know that India has got two issues. One is the socio-economic issues, and with respect to the poor people, poorest of the poor people, as they tell, they can be the political agenda, but really speaking, every government has to look after that for at least incremental development of those people. The Deen Dayal Upadhyaya Gram Jyoti Yojana was that such a scheme where the rural electrifications were given certain importance. So based on these two, rather the previous government initiatives, there is a general trend that government as a policy at least want to increase the access to power to villages and the poor people. And on the basis of that, I will put my question, because I'm not going to remove all the coal-based systems right now from maybe the shortest, within the shortest period, and introduce renewable energy and distributed energy. That will be a complete blunder, because that's not possible. Infrastructure development and infrastructure removal cannot be done instantly, but there must be a definite directions with respect to matching with the current demand. So this is the scenario of one of the census data, that though there are a lot of initiatives has been taken, but even 30% and below connections are there in some of the states like Bihar. And you can find out the better states with respect to are either in southern part or some part in the central part around the capital Delhi and in Gujarat. So we have certain problems with respect to the power accessibility to all the population. So I'm summing up whatever I have discussed about the policy issues. Large-scale power generation will be coal-based. Though my presentation title tells something different, I must admit there is no other option than this for an immediate future, even for a longer period. We have to compromise with our possible option solution in a realistic way. Then, however, national policy also aims to provide electricity to villages, and specifically to the poor villages. Let's see how it can be done. And for villages of India, my question is not that it's an adopted policy of the government, whether the small-scale decentralized power and other energy utilities using local resources be suitable. What is my proposition is something like this. Whenever you are talking about coal-based power, coal is available in certain places only in mines. And as I have shown in my previous slide, that the coal transportation becomes a big issue with respect to overall energy efficiency. So obviously, if we can explore local resources which have for power generation possible, then obviously we can meet the local demand with respect to local resources, and the transportation of energy issue will become almost, very minimum value, or rather no value at all, zero value. So my suggestion is, can we just explore that small scale decentralized power and other energy utilities using local resources be suitable? Let's see. Then another issue has come into the international level and globally, from past to future. The climate change has changed the entire aspect of human activities. Initially, the people are suspicious whether the effect of climate change was a hoax or not. But now the entire world community accepts that it's a serious challenge. You have to address that. If not in the form of mitigation, we have to address it in the form of adaptation. So there were different meetings, and all these names are known to you. It's most important, or the people became most conscious with the Kyoto Protocol, and then over the years there are several international meetings. And interestingly, the climate change issue, as it grows, it just grows. Then suddenly in 2012, the issue transformed into a different agenda, which is called sustainable development. And this is a concept, honestly speaking, though it has been propagated by the Blanton Commissions of the United Nations, the sustainable development is a very good concept. Nobody deny that meet your current need, but preserve for the future generation. Yes, conceptually it's great. But honestly speaking, some people have got a lot of the suspicion about this concept. Which is sustainable? How do you know? Yes, that's a confusion. And in our last conference, we can organize physically at Jadavpur University in 2020 February. One of the rather leading persons of this sustainability thinking, he was EPA, US Energy Protection Agency, Environment Protection Agency Associate Director. He's working in the sustainability concept over a long period, and he mentioned this assessment is very risky. Sometimes the sustainable systems, what is assessed, may not be in future proved to be sustainable. So there is a confusion in sustainable, which is sustainable or not, and which is not. But fortunately, we get money out of the projects, etc., when we add up the term sustainable. Anyway, so the concept of sustainable is that it has to be socially acceptable, economically feasible, and environmentally benign. So obviously, again, I'm telling conceptually this is good, but actually which system is sustainable is very difficult to conclude. And most important complications come from the social sustainability, and to some extent, in some cases, environmental sustainability from the concept of, the cross-coupling issues. Now, distributed generation, an Indian case study. I'm just showing you how we did it. I will try to make a short overview of whatever we are doing, not going into the method or actual technological details how we did it, but we will try to concentrate mostly on the results. So this was a published paper in Energy Journal, where what we have tried to do in northeastern states, especially in Arunachal Pradesh. You know that the power supply is still at a very miserable condition. Many of the villages doesn't have any reliable power. They have their diesel generator set. Whenever they require power, they just simply switch on it for a short period. They do their minimum basic requirement and they just simply switch it off. So there is no electricity beyond that. We started our, in fact, last 4 to 5 years, even more, I'm concentrating on Indian context specific power problems. So here we have studied that the northeastern study, if we can make, whether this power is so-called economically feasible options are there or not, rather than the grid power. Because grid power will not be feasible, that is already proved, that maintaining that particular grid supply with that so high mountain terrain, etc., may not be practically feasible. What I got from the study that this northern, western, southern consumption, specifically in the western part, electricity supply availability is much higher than the northeastern region, almost non-visible. So we have concentrated our study with respect to Arunachal Pradesh. The location is something like this. In fact, in our paper, the reviewer demanded for the geographical, little bit physical view of that particular place. And this is a part of our paper. And if this is the situation, how the grid power can be integrated, for these areas, how the grid power can be integrated. So our only option is to make, if we can make something of distributed generation using the local resources. Now, what was the strategy? Was something like this. Let's assess the local demand evaluation. How much is the demand? In any electricity planning, even for large scale power generation also, you have to have the assessment of the demand initially. Then we make the resource evaluation. The resource evaluation, in fact, is not that important with respect to the large coal-based power, because you can supply coal from your available reserves. But the distributed generation, these two matching is very much important. Then the selections of the equipment, available equipment matching local resources is important. Single renewable resources would be, in a sense, easy to operate, but most vulnerable also, because that resource goes means everything goes. For example, if that resource is solar-based system, then battery capacity will determine the maximum possible availability of power. Similarly, combination of renewable resources, which we call it hybridization, is a good option. But combination means which combination? Multiple options may be available. Here goes engineering optimization. So occasional diesel generator support may meet the load as was checked. It is good, because generally the people have got a sense or other general perception that we should not go for any fossil fuel based system. Don't be that much Puritan, at least our experience says. If there is a 1% operation during the 1% of time operated with fossil fuel based system to make that uninterrupted power supply, that's better rather than non-using it and make an interrupted power supply. Any optimization means you have to decide what optimization tool you will use. We use multi-criteria decision-making system, and then the TOPSIS algorithm of that MCDM system has been adopted. And in TOPSIS algorithm, the basic principle is, that the shortest and the longest distance, etc. I will not enter into those issues because that will complicate the situations for a mixed audience. It was the structure of that, the location and that northeastern states. There are certain PV modules, there are some battery bank, they operate in DC bus system, and there are some AC Here, alternating current system also, there's a digital generator set, hydro module and wind module. Remember, this hydro module is the micro hydro module with respect to those streams that passes over the hills. It's not the large scale hydropower. And then obviously we have the electrical load we can supply, and then in between there must be a converter, DC to AC conversion. So what was our objective in this work was, we are trying to meet the load at the lowest cost and minimum CO2 emission for the full life period. So obviously we have to choose the suitable combinations out of this. Now in the result, the details, I'm not going into this. This is the logic or the algorithm how we reached into the solution. But the paper has been referred. Those who are interested, specifically the students, can find out from my Google list. Anyway, so I'm just final result. I'm showing that the power share of the different modules are something like this in the optimized solution. 57% almost is from hydro, and 41% is almost from the wind, and only 1.94% is diesel generator supply. We recommended is the best possible, or rather I should not call it best, optimum possible solution. Because rather than giving interrupted power supply, it's better to push this almost 2% diesel generator based systems, which is actually existing right now as 100% system, and go for the other alternative hybridizations of renewable resources. So cost share is interestingly not necessarily linearly related, because this technologies, renewable technologies, has got wide varieties of method of harvesting power. So what happens when you go for the wind based technology? That costing is a little bit less than the hydro installation system. So obviously, though the 41.17% was in the optimized solution came from hydro, but that came from 41% wind, but wind is taking lesser power, lesser costing also, but may not be always these two. That means if certain power supply is of largest share, that may not always take care of the maximum amount of investment or costing requirement also. There is serious, very such interesting challenges in renewable introduction. We are all looking for renewable energy, but renewable energies are much more variable issues rather than the central coal-based monolithic problem. I'm telling monolithic, and that is a multidimensional. Because in renewable is also itself is a widely varying thing, whether it is biomass or it is solar or it is wind or it is wave energy. Everything has got its special significance, but they are clubbed together all with respect to a renewable because they are virtually inexhaustible. Now I'm coming to a new concept which is called polygeneration. Mostly we are mechanical engineers in this audience, so we know heat engine thermodynamically. We know cogeneration, what is additional utility is utility heat. Then we know the trigeneration, the next generation, where the heat-based refrigeration system is also used. Now, inputs will be given in a system to generate multiple outputs simultaneously. So here the greatest challenge is the system integration in an efficient way. And this makes the complex system, but undoubtedly this gives a better efficiency and much better solutions meeting many challenges. Even it can be a multi-stage polygeneration system where one block may have certain outputs and some outputs may be used internally for going into another level of polygeneration where outputs will be again of several types. So integrating many inputs and many outputs in a single integrated energy systems is a difficult challenge, and that most probably coming up in future, according to our experience, as a big solution for decentralized solution system, which will be a multi-utility system efficiently integrated. So why it is gaining significance? Obviously, it is efficient. Better utilization of natural resources can be made. Better production security, input flexibility, etc. But challenges is mainly the research needs is with respect to the identification of proper local needs, local resources. Because unless you have these two proper assessment, you cannot make a match. And any polygeneration system development is basically a site-specific solution and needs individual. Because coal-based power plant, when we were talking about the international development of coal-based power plant, is done wherever. It can be uniformly applied to everywhere. But for polygeneration development, the issue is you have to make an innovative solution based on the local resource available and also the local demand. So we are just presenting nothing, only the title and this small result conclusion, not the in-between method, whatever you have done. So This was one assessment done with respect to all of you know in West Bengal, Bardhaman district is famous for rice production. So agricultural waste has become a serious issue. Now out of this rice production, if the agricultural waste straw, rice straw can be utilized, we made a study. It was published, but it's a theoretical study, no doubt. There are a lot of issues will be involved when you go for actual technology implementation. But this theoretical study is the starting point has to be. And it's quite reliable, and the result shows that it's feasible. It's not completely non-feasible or unfeasible situation. So we have estimate like this. And finally, we have taken care of all the process logistics. The process logistics become very important when you want to make something of biomass-based systems. Because when it's a fossil fuel-based system, then the calorific value is so high and being extracted at a central point, then the transportations of that fuel is enough. But in process logistics, the biomass are actually the distributed generation system. Means even the biomass is not in a mines it is available. It is available at different point of source. You have to collect them, process them, then use them. So the process logistics has been taken care of, but the thermochemical utilities, the why it is poly generation was power, ethanol, cooling and heating. These four was the output of that system. Details are there in the published paper. So we have got an estimate that these are the values. We can have a net power output of 33.5 megawatt. The steam turbine power output is something like that. We have got the ethanol production rate that can be used in multiple purposes. Even it can be used as a good fuel. Then cooling rate is something like this. And CO2 capture rate is also assessed. All the details are in the published paper. In another paper, actually, we have tried to, I will not discuss this because due to lack of time, but I'm just mentioning this that techno-economic analysis is an important issue because vis-a-vis the technical feasibility, unless the economic feasibility is there, the system is not acceptable. On the viewpoint of that, that was also studied, and off-grid Indian village has been studied for this. And then in another next step, what we have done is an important issue. You know, a system feasibility is now considered with a lot of importance. During our student days, it was not that much important. Environmental feasibility. Now the environmental feasibility has become a very important issue for any project approval. And in that case, what should be the indicator for the environmental feasibility is internationally accepted as the life cycle assessment, which takes care of the environmental impact from initial inception after the disposal. We call it from cradle to grave. So whatever the impact of that particular system is there on the environment has been integratedly assessed. So in this, there are different, the standard methods now. ISO 14000 is that particular document for which the environmental impact assessment can be done. We have carried out the rigorous assessment and found out all the possible associated issues, acidification potential, climate change potential, and then other issues also, and then find out the contributions of each in detail of that particular biomass-based system. And then we have found out the effectivity of the poly generation. Means if we go for poly generation, then what we are doing? We are integrating multiple utility output in a single system rather than providing individual standalone systems for delivering those same utilities. Now, unless you have advantage with respect to efficiency on environment, why should you go for that? Because the system is becoming more complex. Yes, we have found out that poly generation gives that advantage with respect to environmental benefit also. Then there is another work. This is a very recent work in 2022 only it has been published. We have India has got a long coastal line, and you know that the groundwater is a serious problem in India. So we are trying to get out of it. And you know, some of the countries of Middle East, they completely depend on the drinking water supply on the desalination process. In fact, desalination process exploration has made many solutions in different technological directions. The thermodynamic exergy analysis has been originally started from that point of desalination. Interestingly, this desalination with respect to India, we believe that in short, maybe within some few years, it will be a critical issue because we have got a lot of water, but that water has to be processed to get it for the human consumption. So we have tried to integrate for a particular specific case of a small village of Tamil Nadu, where we have tried to get that particular desalination process integrated with the power. They are obviously like that Northeast situation. Here the demand or the need is different. There the demand was only power. Here the not only power, there can be multiple demand, rather the heating can be integrated into that will further work. But in southern part, where the more demand is basically with respect to desalination requirement. So this desalination's 3 possible options has been chosen: reverse osmosis, multi-stage flash, and the multi-effect desalination process. We have tried to optimize, and then resources also goes on varying with respect to here the solar energy has been integrated. Note that in previously Northeast studies, Northeast is not very suitable case for solar penetration, because that's why most of the companies, commercial companies, are switching over to western part for the power generation using solar systems. Northeast, nobody wish to go there. So solar, insolation is not good there in Northeast part. But here in the southern part of India, Tamil Nadu, one of the district, the solar is the good solution. So resource is most important in decentral generation to identify which is most suitable. And here the system is something like this, just like previous case also. We have certain wind energy, solar cell, storage systems, and diesel generator is also supplying. So it becomes a system like this, integrated system, and we have made a comprehensive analysis, and then desalination system has been integrated. And interestingly, again, like those algorithms are there in the paper, you can find it out. And then optimization has also been done. I'm not going to that part, but the final solution is share of resources and the cost components of the optimum solution. Though in Northeastern state, we started with solar assessment also, but that didn't appear to be feasible. Then here the PV solution has appeared, at least some contribution of PV must be there, but wind has dominated for that particular location. So identifying proper, suitable, renewable resource for that particular place in a decentralized generation is the most important issue. And then identifying the corresponding demand and matching them is the interesting technological challenge. Finally, I just make our review paper in a good journal where we have proposed, and that has been accepted. It's a comprehensive review as a future sustainable energy solution. That's the concept of polygeneration. So in summary, large-scale power generation in India will continue to be grid-based, and it will even be larger in capacity. These names are not given by me. These are given by Ministry of Power. Super thermal power plant, mega, ultra super mega. These are the names given based on the megawatt capacity of Indian power plants. But the national policies aim at rural electrification. Is it possible? Because whatever the ultra super mega thermal power plants will be done, they will not be feasible for supplying power at a affordable cost to the rural electrification purpose. And in addition, there are other mission programs of drinking water, smart systems, means smart energy, smart housing, the smart system, smart city, etc. So integrating these things, my question is, can the distributed generation or utility systems matching local needs and resources be a suitable option? I'm not concluding. I'm just putting that question to the audience. So I'm not concluding anything. Now the house is open for questions and interactions. Thank you. Let me check. Am I out? No, I'm here. Okay, fine.
Well, chairman is there.
Stop sharing. Yeah, that's the thing. Yes.
Hello. Yeah. So many thanks to Professor Sudipta there for delivering a very nice lecture, which even I will request that if anybody has any question, then he is a kind of a think tank in this direction. So if you have any question, you can please throw your question without any hesitation, and we can have a lively session.
I think we should go to the entire participant mode rather than this mode, because this is showing only me, but I want to see all the faces. It's better. So I'll be very happy to share questions, any questions from the students or from the seniors, any feedback, because someone has may have some good experience in the power sector with respect to Indian context. Yes, sir. Sir, please unmute yourself.
Yeah, can I?
Yes, I can hear you, sir.
You can hear me?
Yes.
All right, yeah. You see, I have been personally involved in power sector from 1977 onwards. I'm a great lover of captive power. That's why whichever company I have worked, either they had mega power plant like National Aluminium, SR, or I have coaxed them to go for captive power. Because it was for two reasons. One is I had less admiration for the reliability of the utility supplied power for companies which are guzzling power. As you know, in aluminium, 1 ton of aluminium needs 14,000 kilowatt hour of power. So if we talk of the CSC rate of 10 rupees, 1,40,000 rupees will be the cost of the power. Then when the aluminium prices go down, what is left for bauxite, alumina, the whole process? Nothing. It is really a solidified power. And that is what is done in many places. We know 3 countries. One is Siberia. Siberia has huge source of power which cannot be utilized. So what they did, they put up huge aluminium smelters and they solidified the power into aluminium, which can be readily sold. We go to Egypt, that Aswan Dam on the Niles. It produces on the perennial source. The river always flows. There is uninterrupted production of 800, 900 megawatt. Egypt doesn't consume it. So Egypt aluminium used to produce and export. Same is Quebec. You go to Canada, Quebec, and I have been personally to all these places. In Quebec, the flow of the water has a big fall, and the Canadian government, Quebec authority, basically sold not the right to that you have a right on the water or anything. They sold to Alcan, Aluminium Company of Canada, the right to tap the potential energy difference between the higher level flow or lower level. They say you are free to take water on the upstream or downstream. But if you want to take advantage of the potential energy gap, you have to pay us so much. And we all know Alcan became one of the largest aluminium smelter, and Quebec supplied all the power through 765 kV lines to USA because they could not use it. Now, any developing country, we probably have crossed a little that, but now you cannot think of the unconventional routes, hydel, nuclear, natural gas, these resources you don't have. So eventually you have no option like China that you have to increase your thermal power generation based on coal. There is no doubt about that. Because if you try to think too much about environment in a indirect way, that I kill the power generation, that means I cut off my head, I will not have headache. That's not possible. You need to grow, you need to have economic growth, and you have to address how you reduce the carbon emission. That's a different subject. You can't say stop the coal-based power generation and the coal emission, I will meet such and such protocol. That won't happen. Now, one of the questions I will ask you, Professor or Sudipta, this has been my question. I had good relation with whether CEA chairman or various state electricity board or NTPC or power grid. I ask you one thing. The global average of developed countries of power distribution loss is about 6 to 8%. In Norway, etc., it's 4%. In our case, it is about 22 to 24%. Now, out of this, okay, let's take away the theft part, because what we give free, Mr. Kejriwal, what he gives free, these are accounted. These are not unaccounted. This is within the billing amount, and this is paid by the state government. Mr. Kejriwal has to pay to the utility distribution company for the power he is giving free 300 kilowatt hour, whatever it is, to people. Now the question I'm asking you, that we have 24% come 20%. If we are at, say, 12%, we have 8%. 8% of, let us say, our generation is about 100,000 megawatt, I think. 100,000 or 120,000 megawatt is our installed capacity, or it may be a little more than that. Now, this saving itself is, say, 8% of 120,000 megawatt is 10,000 megawatt. 10,000 megawatt is worth 50,000 crores of generation, equipment and installation, power plant making. If we look in a reverse way, that, and mind you one thing, we talk of theft, etc., all these things, but the basic loss is distribution loss, not the transmission loss. In my those old time, I have seen in Shiliguri and others, in Bihar even today, the day you will put a 11 kV line out of those all aluminum diesel conductors, next day it will be cut off, because all the Batan companies, they run with stolen aluminum conductor. So eventually we found that a lot of distribution lines are running on steel, just steel. This, they're using standard steel to, and where the distribution loss is 60%. I square R loss, I'm talking of the copper loss. Now, if the country on a sustained basis, you see, we always love to work for things which are exciting. I had once asked UP State Executive Chairman, why you want to put up another power plant? Why you don't reduce your transmission distribution loss? Because you need to reinforce your grid. You need to have more sort of grid, more distribution lines, absolutely network, so that the loss goes down. Otherwise, on an 11 kV line, if you pass power, which is what, 33 kV, and it gets heated up, your losses are mounting. So why don't you make more distribution network? He says, Dr. Bhattacharya, I am chairman for 5 years. I would like to have a power plant with a marble stone where it will be written, inaugurated by such and such minister, and chairman cum managing director was such and such. Now, this is the mentality of the country. Otherwise, if we really think of that, we are wasting 10,000 megawatt worth of power which we are generating, we are losing it, excluding the theft. We are just losing in distribution loss. Now, this distribution loss, basically UP, Bihar, Bengal, it has improved dramatically, I must say, than what it was in old days. I'm not talking of CPM, Mamta, anything, but I know from 77 onwards. So one of the projects which we should sincerely take up, which is, I know, is less exciting, but are more rewarding, because 3.5 megawatt here or in Manipur, or I have a house in Palampur in Himachal Pradesh. Himachal Pradesh, I get power in that house at 2 rupees. Why? Because the entire power is generated from the, the tidal, from the snow peaks during the monsoon and during the snow melting period. And the power is so much excess that they give it to Punjab, Haryana, and they have an agreement that I will run dry for 4-5 months. At that time, you please displace it, and for this displacement, I give you so much. Now, so there are states which are so rich in power and so clever, but at the end of the day, you cannot start to whole solution. That means I will solve Manipur, I will solve Nagaland, I will solve this, and that as a whole will solve India. It's we all remember in childhood that mechano game, that small parts we join and it becomes a car. Because we know it's a car, we are able to join those parts. But if we are not told what is the final part, we cannot join those parts. So we have to follow whole to part theory and not part to whole theory. And this whole to part theory essentially will mean we should parallelly, these are excellent, this solar energy, nuclear energy. I have at least no word about nuclear energy. I think it's quite efficient. Desalination, what you said, I've seen Dubai, Alba, Bahrain, that the entire cities get water out of desalination plant, and their desalination plant is for what? Meeting the power plant. Power plant is what? For aluminium plant. Dubai aluminium and Bahrain aluminium. Together they produce 1.5 million tons of aluminium, fully for export. Natural gas-based power plant with desalination plant. So I admire all of them. But if there is no excitement in working on the basic, that means why 22%? I cannot reach Norway of 4%, but can I reach 16%, 14%? If I can reach, then what you are saying, what excess power you are having to reach people is enormous, because the process by which it will reduce is a process which is making distribution lines, 11 kV, 33 kV lines, enormous amount of substations, and reaching people at 440 volts, which is network strengthening. But we don't want to do it. If all people are happy, we will not. Anyway, the other just small clarification I'll give you. You see, electricity is just one of the form of the energy which is needed to reach people, reach cinema hall, reach industry, everything. But the energy source, fossil fuel or other, the ratio is not 60-40, because there's all this vehicles and other things come. Our total fossil fuel in the country is 75%. 25% is non-fossil fuel, because we have to take into account so much of natural gas is used for the urea. You have no option. The automobile sector, the transport, so we have to leave. These are nice to become free from emission, but we have to double our energy in the next 6-8 years. Because only saying I'll be a 5 trillion company will become a political slogan rather than reality. For becoming a 5 trillion economy, you need power. That is the first requirement, power and water resources. All this Karnataka, Tamil Nadu, this conflict, Kaveri conflict, all could have been solved instead of keeping it politically alive by this theory of desalination plants. That means I basically make the water conversion from saline water for people, let it cost 2 rupees, 3 rupees per liter. Today we buy bottled water 10 rupees 1 liter. So let it be distributed to people, free, subsidized, but the byproduct is power, which solves a lot of village problems in Tamil Nadu, especially. So, because Tamil Nadu, Karnataka, both will have problem of drinking water and domestically usable water in future. So, I personally strongly feel that while we should work on the small parts which are very exciting, we have no option but to work on doubling on our power. We will not have natural gas. Coal is our main resource. We have to use it. And then a very large group of scientists has to work how to reduce the emission issues. That's a different. China has done it. China has reduced their pollution significantly. Emissions significant. Anyway, I think people will say, who is the speaker or the Sudipta? So, because I have been involved in power, whichever company I've worked, I have set up even power plant, a lot of power plant myself. So, I captive power plant has that big excitement that you take away the problems of transmission, theft, etc. You just have a grid connectivity, and theory I give, I take back, because grid has a huge stability. To run an arc furnace or a rolling mill, even a 500 megawatt unit will have ramp if you try to connect. Best is put it on the grid, which can take all garbage and shocks, and then draw the cream and run your plant. So, and for that you pay to the electricity board rate about 20 paisa for, this theory of giving and taking it back. So well, I liked very much this presentation, and I think it's extremely good for the students to know where we stand on power today, because that is the number one requirement of economic growth. We are not a small country like Norway, Australia, or New Zealand. We are like China. So if we have to grow, if we have to give affluence to people, affluence means, better standard of living. I'm not saying they have to really become American. So we have to produce more and more power. Creating hatred against coal-based power will be disastrous for the country. Thank you very much.
Sir, it's excellent, sir, because this forum that's why very much attractive to me, because senior experienced persons like you is giving the feedback. I'm really grateful to you. So just few points. In my presentations, I fully agree with you, 100%. India has no other option than coal-based power for longer future. I mean, we have no other option. And interestingly, whenever we go for any policy decision, then as I have mentioned that, in fact, I get aware with more through my international collaborations. In our academic institutions, the engineers doesn't talk to the social science people because they think that they are completely different people. But any new energy initiatives are supported by the corresponding socio-economic researchers, because what will be acceptable, that will not only depend on technology, but also depend on socio-economic constraints, where it will be accepted, where it will not. In fact, in our last two Norwegian collaborations, there were the socio-economic group parallelly in Jadavpur, and parallelly in Jadavpur has got that tradition of interdisciplinary research. Now answering, or rather not answering, completely matching with your viewpoint, whenever you are talking about the captive power plant, that's a basically industry-specific need for a particular specific industry. But my title is also not moving towards distributed generation. My title was step towards, means it is just a complementary to the mainstream large-scale power. Means if we can provide some solution with new renewable resources, with locally very, where the grid-based power may not be feasible, I just concentrated on that. But I agree 100% with you that with respect to Indian context, in the visible future, unless there is a disruptive technology, we will not have any other alternative solution than increasing our coal power. But the percentage increment of coal-based power, as per the Ministry of Power's document also, is decreasing. So hope that this is basically under international compulsion. And obviously we have to think of that situation right at this context, because the fossil fuel-based systems not only constrained with respect to climate change, but the resources also up to 200 years we have the solution. But unless we can try getting alternative solutions, again, I am agreeing 100% with you. In my presentation also, I mentioned that we have to have coal-based power, and these solutions are only for local regional solutions with better options of new introductions of areas of power. Don't put new areas, if possible, with combinations of renewable resources. So I agree fully with you. India and China doesn't have alternative solutions than having even better coal-based solutions for near future, maybe for next 50 years at least. Thank you, sir. Any other queries? And just one point I want to mention, that as you have mentioned, that reducing loss in another presentation I have just mentioned is very rightly that generating 1 unit of power with whatever efficiency is much lesser efficient than reducing 1 unit of power loss, because that means that's with 100% efficiency. So obviously, effectively going for that, I must admit that I was in very close contact with Bureau of Energy Efficiency, Dr. Mathur, etc. India has also taken that initiative of BEE, Bureau of Energy Efficiency. You might be very much aware. And that concept of that availability-based tariffs, etc., and then reducing the losses has got certain component, as you have rightly mentioned. That's why I have also made it a difference between the transmission distribution loss and associated technical and commercial losses. Because if some people want to give some subsidy is very much required, and wrong subsidies may be a future destruction point. So whatever will be done, then we cannot deny that socio-economic constraints, and within the socio-economic, we don't mention it explicitly, politics is also involved. No country is out of politics. We have to go through that particular solutions for national level solutions. So I fully
another thing which has always haunted me is, I put up a small plant in Houston. In USA, you put up a plant, you tell them which day you want 3 things: natural gas, oxygen, nitrogen. It's in a grid. It'll just be connected to you, and they will put the meter, you go on paying. And here, to put up an industry, you have to engage sweeper, to shoes teacher, to things. If I am a steel plant, why the hell I should make some power, oxygen, nitrogen, everything? India should think oxygen is a very good source of energy for certain use. For converting iron into steel, it generates much more efficient power than any power plant. Now, we must look forward India on long term to create grids for these 3 things: oxygen, nitrogen, and natural gas. Natural gas, we have made some progress, Bombay High to Hazira to Uttar Pradesh, then all the states, then it has finally come to West Bengal, Durgapur for a fertilizer plant. I understand it will come to Kolkata for, domestic supply, etc. So the concept of central big plant with grid, I admire it. I like it. There's too many oxygen plants. Then when you had a COVID problem, USA, etc., did not have that. I don't have oxygen. I know we were rattled. We were rattled to get tankers and moving from here to there, there to there. No, that does not happen if you have a grid which is monitorable, that where you will give how much.
Sure, sir. Thank you, sir. Thank you for your input feedback. It's my learning. Anybody
If
else?
I can make a point.
Yes.
When you talk about, or when you say that coal-based plant is going to stay, I think you are also considering carbon emission aspect of that. So how do you see the clean coal technology aspect here? Because traditional coal-based power generation, I think from environment point of view also, it's not really, it cannot really sustain. We cannot allow it to continue, I think, for more than a decade or 2. So do you think
decade? You will close down NTPC in 1 decade. Good.
In fact, you have certain working jointly together also, but I can just refer to your question as just one of the persons or participants. So I can just tell you that feedback, the clean coal technology, my thesis topic was on clean coal technology. Entirely, the title was that. But the clean coal technology is a generic name, but the practical feasibility of clean coal technology depends on many issues. In fact, I was lucky to be involved in one of the European Union project, H2IGCC, where the concept was, that the why we call the clean coal or the dirty coal technology, that means of how much emissions we are having. So the emission issue, mainly with respect to, is now concerned with ash is a problem, etc., etc. NOx, SOx is also a problem. But most important issue with respect to international context is the carbon dioxide. So the carbon capture has become an integrated part of the using coal with respect to future possible options. Now, the carbon capture can be pre-combustion capture, can be post-combustion capture. The pre-combustion means you will remove the carbon part of the hydrocarbon fuel before the combustion. That obviously will lead to the hydrogen burning, and it's a clean fuel. And post-combustion is allow the carbon to burn and then separate that carbon dioxide that is getting emitted. Each has got its own limitations and advantages. I'm not going into that detail. But issue is at least the H2IGCC project, which just explored the available technology in European Union with modifications of the hardware, because when you go for hydrogen-based systems with pre-combustion capture, then obviously the gas turbines, etc., has to be modified accordingly to sustain at that very high temperature, because hydrogen-based combustion systems will be comparatively at a higher temperature. So that European Union H2IGCC project explored for that, and that led to assessment of 24% cost increase. So obviously that has recommended that though the technological possibility is there, but feasibility is restricted with respect to economic feasibility. And that's why the concept of sustainability is coming from different viewpoints. Honestly speaking, nobody knows if the clean coal technology evolves with the cheaper options will be acceptable or not, because it has to be. But on the other hand, if you find out in the last meeting of the Glasgow, last time, there the keeping the carbon under the earth is the international opinion going towards that direction. Whether it will be technologically feasible or not, that will subsequently explode. But society goes by the perceptions and the political leaders of the nations also. So I can tell you, according to your question, in Indian context, at least I made one of the Institute of Engineers organized program where the government of India has already made mandatorily FGD, flue gas desulfurization. But interestingly, all the power plants are not yet ready for that. And you know, through jointly working between you and me, that biomass co-firing has already been recommended.
Yeah, that NTPC has started, yes.
But the entire system is not ready. So I'm not going into the Indian context, or rather, I'm not going to
That's another issue, yes.
Indian context has certain issues, and obviously each country has certain issues. Like Sir was mentioning with respect to the Norway. Norway, I have got collaborations. I know that they are quite lucky with respect to having uninterrupted, hydropower. That's the, yes, they sell their fossil fuels, they sell their oils for their economy for other countries, and they generate their own power from the hydropower. And they're lucky with their natural resource. We are unfortunate from that. And answering to Dr. Ghosh's questions, actually, my answer is whether the clean coal technology will be a better solution. It is being explored, but at least my perception goes that is not economically very much feasible appearing to be till date. So,
particularly in Indian context, because
yes,
IGCC is also not really coming up that way.
IGCC, and you know yourself better than me how the fuel cell was thought of to be a better solution with respect to fuel cell integrated.
Yeah, we once thought, but
yes, but fuel cells also that has not been proved to be a large-scale solutions economically feasible. And that's why the term sustainable, though it is sometimes misleading, but still I feel that the term sustainable concept is very good. That means solution acceptable may not be monolithic based on better technology, based on economic feasibility, environmental feasibility, and social acceptability. So that's why which one will be the most successful in real life, apart from laboratory experiments or publishing papers, that future will say. We can go on just reporting.
And how is your experience from European cooperation? Means you must have better access to information of renewable energy sector there in Europe. Are they going for centralized sector? Renewable energy, are they feeding to centralized grid or trying to go for decentralized systems?
European Union also, there is no uniform system, because European Union is economically they are united one single entity, but country-wise they are all separate and their natural resources are also different. From at least my experience of collaborations, I know the Norway obviously, you know that they have converted into even their transport system also, most probably as far as I remember, because in my visits I have found out they are all registration of the vehicles of named as EL, starting with when it's the electrical vehicle. And they have made it mandatory as a rule after most probably 2024. They will not manufacture any fossil fuel based transport vehicle. So interestingly, they can decide it. But our country is also moving towards electric vehicle. Another important debatable issue, because there are different lobbies has got different opinions whether we're going in the right path or wrong path. But I can tell you that Indian context, there are two issues that control the entire economic conditions of India. One is the monsoon rain. If there is any disruption, we will have the lesser agricultural product. Another is the international price of oil. And now, if we want to come out of it, and the international price of oil is now affecting all over India, now we are getting affected. So more the problem or not, or it's a political problem or not, whatever may be, that affects the society. So I can tell you that in which directions, for example, European Union experience, as you have asked me, the Norwegian solution, when we started initial collaboration, I made my presentation from my Indian side, what are the challenges from Indian power sector, and they made their presentation. I found out their problem is they don't have any problem. That's why that's the problem, because they have.
Our main problem is we produce 6 Norways every year. India's net population increase is equal to 6 Norway every year. That's our problem.
Maybe, sir, as you are telling very rightly. In fact, they went from Kolkata to Shantiniketan to see one other project, UK based, and they have told that they have seen their total number of vehicles in the journey more than their own country. And they have found out that the driving rules they face, they tell that in India, one of the drivers has told them, in driving in India, then it's only three things. One is the good horn, another is the good brake, and another is the good luck. And he was very happy with that conclusion. Again, coming to Dr. Ghosh's question, actually, that with respect to European Union, I've seen at least two countries, not very closely, but obviously from outside, I should not comment with some 100% confidence. But in Germany also, I found that when we are in collaboration, that Germany is one of the countries in the European Union who depend on the coal, Germany and UK both. But Germany, I found out that initially, I just forget the year actually, but I can have to recall, that time they were just propagating the solar power. So 2,000 rooftop solars, then 200,000 rooftop solars. These are the names of their project. But later on in our project continuation, in the next year when the German people came, they told that government has just taken away all those subsidies for the solar propagation, and they are rather promoting again coal-based system. This is sometimes very much required for making an evenly balanced.
I will tell you one thing. All this Germany, USA we are talking about, they are all making all these things after becoming developed, affluent. Can we ask, we have friends here from USA, can we ask how USA became developed, say, we go back 100 years? Did they emit or they did not emit?
In fact, the answer can be given to the person you have put, but I can just add up. There lies the so-called climate politics has converted into climate justice. So that's the issue, because Indian emissions, always in international negotiation, we say, you have the total CO2 emission divided by the number of populations. We will be champion, because per person, if we consider about the emission, will be always very small per capita. So the question you have put to the person, he can answer. But my idea is US, at least in my perception from the academic literature, is not that much conscious of energy conservation as the European Union is doing. At least in European Union, I personally myself have seen that people has got their very good mass transportation system. In spite of people having cars, they prefer that. But as far as I know, USA doesn't have, if I make it wrong, sir, please correct me, because I'm not telling it with my experience much of in US, but at least the literature says that the general individual transportation system is still dominating in US rather than the public transportation system, which is
In
not.
USA, you can buy a 100-year-old car. You have no problem.
Yes.
$500, no problem.
So the question can be answered by the person you have given put to sir.
Well, our scholars have no questions.
Now, sir is telling something. I mean, I think, sir, you are muted, sir. You are muted, sir. Unmute yourself.
Kamalda saying something, not able to hear.
Yeah, you have to unmute, sir. No, not.
Kamalda, you are muted. Unmute yourself. Kamalda is calling from Texas, joining from Texas.
So still you are not being audible. You are muted.
Yeah.
Something is wrong, Kamalda. You are unmuted, but still nothing could be heard.
Is it the problem with the headphone?
It happened one day with Uchudra also.
Please remove the headphone also. Headphone, then you talk.
Yes, sir. Remove the headphone and directly talk to your speaker. That may be better. Maybe some connections of headphone is creating the problem.
Maybe you can remove and directly.
And remove the headphone connections from your computer also, because that may be not properly connected. That's the reason maybe. And removing the headphone connections to the computer, you state directly. No, still not.
Still, something is wrong, I think. But you can put your question in remarks if you can.
Yeah, it's unfortunate. We could get some sharing of experience from senior persons, but unfortunate. Okay, technological snag.
No, Kamal, you can't hear. Maybe you can write your question in chat box. Today we have a lot of audio-visual hiccups.
Any questions from the younger generation, the students? I would be happy to answer their queries.
I was also noting your PLF figures. Interestingly, both central side as well as state side, PLFs are gradually going down. So probably it indicates that as we increase our install capacity, we are not able to, I mean, we are trying to bridge the gap between demand supply, but in the process we are losing PLF.
Here the interesting part is, I mean, though I teach power plant engineering and I've got a textbook of undergraduate level, but unfortunately I must say that I tell my students that a coal-based power plant industry may not be your very safe career for throughout your, say if I take a career of 30 years, that may not be very safe. Means relatively there will be better lucrative career in other fields of power generation. And honestly speaking, the world changes. That's why it's a living world. And as I can tell you that the PLF is decreasing is as many companies are really in very serious situation, like DVC, the other companies, large scale companies like NTPC, etc. They have got their PLF little bit better, and the central PLF is little bit better.
But for them also, the central sector means it's NTPC
They're also
or
decreasing. That is also decreasing. That is also decreasing. But the state sector has much more obligations with respect to compulsory supply to some of the sectors where their recovery and their evenly distributed demand is not there. But supplying to the, I mean, industries, as Mr. Bhattacharya is also mentioning, that's a like captive power plant. That demand and supply is automatically matched as per design. So that's the most comfortable situation. But catering power to the domestic sector, especially to a widely varying populations with respect to economic condition, is a very challenging issue. So there, these PLF issues will touch up. But one of the important issue of PLF decreasing is obviously the renewable integration, no doubt about it. Because every country has made, every company has made under regulations, compulsorily certain percentage, as far as I believe that 20% or so in India has to be from the renewable resources. And that may have a particularly indirect effect on the overall PLF of coal-based power generation.
Great.
স্যার কমলবাবু কি মনে হয় চেষ্টা করছিলেন, উনি এখনো কি শোনা যাচ্ছে না কেন? যাক ওনার ফিডব্যাকটা পেলে ভালো লাগতো। সিনিয়র এক্সপেরিয়েন্স লোকেদের ফিডব্যাকটা আমার কাছে ভ্যালুয়েবল।
He got disconnected, I think.
আমাদের কলেজে কি ইয়ে আছে, এই পাওয়ার প্লান্ট ইঞ্জিনিয়ারিং এর উপরে কোনো কোর্সেস আছে?
স্যার মেকানিক্যালের থার্ড ইয়ারে উই হ্যাভ টু টিচ, মানে as far as I know, at least now
B কলেজে কথা বলছেন?
B কলেজে কি
হ্যাঁ,
স্যার বলতে?
মানে আমার কলেজ বলতে তো
In B college we have one course of power plant engineering, but
Power
that's
plant
now
engineering.
elective. Earlier we used to have a compulsory course, now it's optional one.
In Jadavpur, where I teach, though my all, I'm a graduate from Shibpur, there that we have just made a concept of, we are not telling it power plant engineering. We are currently telling it energy conversion methods. And in fact, just to squeeze the new knowledge within the same available time period, we have to combine many things together. In energy conversion methods, it's a compulsory subject in third year still, and the power plant, coal-based power plant component is decreasing slowly over the years. We have to now teach renewables, including solar, nuclear.
Yeah.
So as if the other share of the total other possible power options are increasing in that course, decreasing the coal-based power options. But still it is made compulsory because we feel that students should have a compulsory exposure to that subject.
Sudipta, one thing
Yes,
I'll
sir.
just make a comment, because when you have say Nalco, we had 1,000 megawatt captive power plant. I think now it's 1,200. In my time, it was 760. Except the hatred against the coal's problem, the ash, CO2, sulfur dioxide. For a mechanical engineer, the power plant is a dream plant to learn. Means if you really talk of the turbine, the boiler, the electrostatic precipitator to ash handling plant, etc. For a mechanical engineer, there cannot be the substation, the SVCs, those technologically, even those SVCs, etc. It's a marvelous place for mechanical engineers to work. Only problem is it has become a bad boy for the behavior of the coal, not the plant.
So interestingly, we had a program on mechanical engineering education at Crossroad at Jadavpur. And we tried to bring the different specialization area people of mechanical engineering. Someone came from power plant engineering, someone came from consultancy organization, someone came from manufacturing sector. And we want to take the feedback of those industry people to get what should we teach these young engineers. And there was a controversy because when the person came from power plant, he is or she is promoting most his or her baby. They're telling that that's the best possible option in mechanical engineering. When you are coming to the manufacturing or material science, they are telling the most of the content should cover that mechanical engineering part. So, and consultancy company, they are telling, why don't you teach some of the code reading and the etc. etc. So that's a debatable issue because I born and brought up in Uttarpara, which is closer to the Hindmotor. And during my student days, my training was also in Hindmotor. It was a brilliant company for learning many aspects of mechanical engineering because almost all the aspects of the manufacturing engineering were available in that plant. But that has become age-old traditions and that is gone. So we
But
cannot.
Ashok, I'm waiting for the day when Infosys and TCS will recruit MBBS people as their, adjoining level, because they have taken architecture, mining, chemical, irrespective of any discipline they have recruited for them.
Actually,
Why
I
not MBBS?
have some certain connections with higher education also. In recent past, I have done some on higher education with the European Union, one project involving NAC also. There was one concept promoted in MBBS, rather in medical profession. There is the initial starting degree is MBBS. It's not any specialization in anything else. But after that, the specialization starts. So one of the concept was mooted in that particular meeting. Why not there is a general MBBS sort of general engineering, who will know partly electronics engineering, partly mechanical engineering, which are the basics as we consider. Making the syllabus is very difficult. But if we can do that, then the specialization starts like medical profession. Someone will go for orthopedic, someone will go for pediatrics, someone will go for cardiac. That may be in future science, future engineering aspect that may happen. But defining the similar course like MBBS is very difficult in engineering most probably because we have discipline oriented and our background motivations or other bias in the brain is something like that. We mechanical engineers, we chemical engineers, but at least from my experience of last 5 to 10 years, I must say, in interdisciplinary areas involving even social science people, I found out that we are not much ready. I'm telling regarding myself, I should not tell we, much not ready to listen to others. I'm moving with our ideas, but when it comes to socio-economic constraint, most of the engineers say it's not our responsibility, you manage it. But actually in real life implementation, as you are from person from industry, even the socio-economic issues sometimes dominate over the technological best possible solution in real life industry.
We could not take any question from Kamalda. We can check up once again whether he is available now. Kamalda, can...
Yes. He was trying most probably. Then again, some network problem.
Yeah. So I think
I'm available, but rest of the people, they have some other times actually. Now the participation also decreasing.
Yeah, participation is falling. So maybe we will wind up. Kamalda, can we speak now? Okay, okay, okay. So we'll call it a day today. Maybe we'll wind up with the permission of the chair. On behalf of the department and on behalf of the Centenary Celebration Committee, let me thank Professor Dev for giving this talk, for taking time off from his busy schedule. Thank you very much. Thank you. Thank you. I should also take this opportunity to thank our session chair, Sir Ashen, Shekhar, Professor Datta. I must thank our today's session chair, Professor Shekhar Chandra Datta from ISM Dhanbad. From our department, I would request our session chair to virtually hand over a certificate of appreciation, if we can show it on screen, volunteers, and a memento also. The memento will arrange to hand over to the speaker somehow, either here at the department or maybe we will be sending it through somebody. So here is the memento. So just a token of appreciation. So thank you very much. And thanks all the seniors members of alumni who have joined today. Achyuta was there. Sir is also there still. We are missing Professor Ghosh today. Usually he comes up almost every Tuesday. And so is our Kamalda. Mr. Palit is also there today. So many senior members who
and Mr. Palit has joined from Cheltenham, UK.
Oh. Thank you for joining.
Mr. Palit is not in India, but still he has joined.
That shows the interest and the connection. Thank you.
Institute connections is the most important
Thank
issue
you
here.
for joining.
Speaker is not
Oh,
the issue.
Achyuta এসে গেছেন at the end. Thank you, Achyuta. So we'll be winding up now. Thank you, one and all. Thanks. So volunteers, we might